So, electrons were first identified by Joseph J. Thomson, an English physicist, in 1897. So electrons were first referred to as cathode rays. Now, Thomson used a cathode ray tube to make cathode rays, which are negatively charged particles that are made by a cathode, a substance that emits electrons. Thomson's research proved the existence of negatively charged particles, now called electrons. And his research led to further discoveries by Bohr and Rutherford, leading to an understanding of the structure of an atom. So Thomson had 3 cathode ray tube experiments. For the first one, Thomson tried to prove that the rays emitted from the cathode ray tube were inseparable from the latent change. Now for this experiment, he used a magnetic field. He then built a cathode ray tube with a metal cylinder on the end. The cylinder had 2 slits that had electrometers that would measure the very small electric charges. Thomson discovered that when he put a magnetic field across the tube, he didn't seem to find any electric charges measured by the electrometers on the cathode ray tube. From the results of this experiment, Thomson found out that the cathode ray and the negative charge were not able to be separated. So Thomson continued his experiment and conducted a second one, in which he aimed to prove that the cathode rays were negatively charged. In this one, he tried to deflect the rays with an electric field. He made a cathode ray tube that was different from others. For this one, he coated one end with fluorescent coating in a vacuum. He then put 2 electric plates towards the middle of the tube. Those plates caused the making of a negative cathode and a positive anode. Thomson used the negative cathode and the positive anode to try and deflect the cathode rays. As he had predicted, the cathode rays were deflected by the electric charge. This further provided evidence that negatively charged particles made up the cathode rays. But Thomson did not stop here, and he indeed went to perform a third experiment. In this one, he attempted to find out the nature of these particles. The particles were extremely small, so small that you would not be able to find their charge or mass. So Thomson tried to accomplish this by recording how much the particles were bent by electrical currents that had different forces. Thomson discovered that the ratio of charge to mass was incredibly large, and that the particles either had to be nearly 1,000 times smaller than a hydrogen ion, or that they had to have an incredible charge. Now, Thomson made a big step, saying that the cathode rays were made of particles that emanated from within the atoms themselves. Now, this experiment was huge because it led to so many further experiments that really understood the complexity of an atom structure. And without Thomson's, model, then, Rutherford and Bohr would not have just had the model that they had. Without the information that Thomson discovered, these later discoveries by, Rutherford and Bohr, probably wouldn't have been possible. And that is why, Thomson's cathode ray tube experiments were so important.